And I'm unmuting.
I have started the recording. I'm going to kick it right to Mr. Martin now.
Okay, I'm going to. One question I'll have right away is that you're seeing me in this black background, and that's one question that I need answered. So,
yes.
Yeah, we're seeing the background picture you have.
Okay. All right. So today we're going to do talk about a topic that probably a lot teach, dealing with alignment, some of the angles that we teach, some of the other ones that we consider to be non-adjustable and things that affect them. This is something I put together a few years ago, but always sparks conversation. The other thing we're trying today is we're actually doing some testing with using green screen technology and a couple of other little tools. So just trying to take another tact at the way we're delivering. So with that, we're going to get started. So I'm going to switch to that. And again, here's the title that we're going to. And what we're going to deal with here is using a lot of virtual shots of this trainer. This trainer is our EM130 steering and suspension trainer. It's based on a Hyundai Accent, but it really wouldn't matter what vehicle it is because we've changed so much about it. A couple of things we've done is we've actually added adjustable plates to the top of the strut, so you can actually change camber and caster up there, which is not part of this car normally. We've also got some adjustment handles here and on the other side over here that allow you to change the ride height of this. You can actually change the tilt of the frame, those types of things as well. And then it's all mounted on a rolling platform and has turntables below the wheels and tires. The springs on it are actual not springs, they're just a piece of plastic hose so that there's no undue loading on steering and suspension as we try to use this. So like I said, we've got that unit, but we're going to use a virtual version of it. And you're going to see me popping in and out. So this is just a side view of the same unit with the tire off, so you can kind of see the orientation. Facing the right-hand side of the screen would be the front of it, and the left is the rear. When we start talking about wheel alignment, we start getting into our adjustments and, you know, our measurements. You know, these readings could be in inches, millimeters, degrees, whatever, but we have positive and negative numbers that we're going to use, and we're looking for somewhere in that green area when we have a specification. Yellow is it's close and red is it's way out. But one of the issues we run into sometimes is tolerance. You know, if you were to look at the readings on this screen, you know, everything's green except for the toe, and it's not that far out. But if we start looking at the real numbers, you know, we've got a half a degree difference in camber, which is really going to build a pull into this thing and is, you know, not really the best. Tolerance is one thing, and it's something I used to teach all the time, is take the factory specs and go and knock the tolerance down. And as some guys have been talking just before we started, in ADAS classes now they're telling people that, you know, you need to start thinking about alignment, make sure alignment is very accurate, because if you've got a thrust angle in the vehicle and your cameras are pointing straight ahead, but the car wants to go off to the right or left, well, that's making a big difference in the adjustment of your camera angle. So we're going to talk about movement of arms. So if we think of the blue dot on the left is the pivot point, and this arm is going to move. We move it back and forth, but the other end of it that's actually free swinging is going to travel in an arc. And depending on the length of this arm will depending on the distance it moves. So we've got degrees of movement, but it really depends on the radius of the circle that we're dealing with, you know. So we're talking thrust line, we're talking from the front axle to from the rear axle to the front axle. But if we're talking a control arm, we're only talking a foot to a foot and a half of distance. So we always got to be considered that a degree, yes, is a constant, but the distance that a degree is always slightly different. Probably the angle we talk about the most would be camber, and the reason we tilt a tire is so that it forms basically a conical shape and creates this tracking of the wheel in a straight line as we try to hold it in place. Camber is probably the most common adjustment next to toe, and usually there is vehicles that have some adjustment for camber, but there are some that only allow you to adjust toe. Short, long arm suspensions have been around forever. Probably the only place we see them anymore is usually in pickup trucks, where we got a pair of control arms that travel in different arcs. We've got a spindle mounted between them, the tire mounted on there, the spring typically, there were other locations for sure in the past, but typically now mounted on top of the lower control arm between the control arm and the frame. And it's how we support the vehicle. Getting into actions of this setup is something, that maybe we haven't talked about before. And what I'm talking about in this picture is instant center. An instant center is where we take a line or the projection line of the control arms and find out where they meet. So in this case, we've got the upper control arm and the lower control arm that if we follow the projection line, they meet outboard of the vehicle. So this would be referred to as instant center outboard. And in an instant center outboard, when we corner the vehicle, we're going to get the frame to actually lean over in the opposite direction we're trying to go. But it also, in this case, instant center outboard tends to angle the tires or change the camber and cause them to lean out of the turn. As an avid motorcycle rider, one of the things that's often brought up is that cars lean the wrong way. So cars tend to lean out of a turn. It would be nice to get the tires to lean into a turn. So we can also do what's called instant center inboard, where we now see the change in the angle of the upper control arm, and now that intersection point is inboard of the vehicle. And now when something like this corners, we see that the tires are now actually leaning into the corner. One of the things about this, though, is that another piece that's not often talked about is roll centers. And if we go too much instant center inboard, you'll actually end up with a higher roll center. So you have to be cautious about that. Just as an example of instant center outboard, this is my car, not my picture, but my car before I owned it. But as you can see, the wheels sag, you can actually see that this was an instant center outboard vehicle, because now, as we've taken the weight off the wheels, they're actually cambered in at the top. And I'm currently in the process of changing it to instant center outboard so that it's more of a streetable car than what it's doing in that picture. So another thing that we want to get into talking about is steering axis short long arm typically has quite a bit of camber change as we cycle the suspension. You're going to start to see a lot of vehicles these days that now use multi-link to minimize the amount of camber roll or camber change as the suspension cycles. So we can see that this thing has multiple points of contact. There's usually 4 or 5 axis points. You'll see in a lot of modern vehicles. Now you do this in front and rear suspension, and again, to minimize the amount of camber roll. As we go to a more common type of suspension that's been around for 30 plus years, the modified strut suspension, where we've got a coil spring and a shock absorber unit built together, mounted to the steering knuckle mounted to the lower control arm. And this thing will also have its own camber change as it moves through. The lower control arm is going to travel in an arc, but the upper mount of the strut also is usually mounted in rubber or a bearing of sorts, and it's allowed to tilt a little bit as well. So we have still the issue of camber change, but not near as much with this suspension. By putting a tire on here, I want to get into discussing the next thing, which is steering axis inclination. Steering axis inclination is if we take an imaginary line and draw it between the two pivot points. So in this case, the upper strut mount and the lower ball joint. And this is going to create a contact point of where that intersects the road. And then we compare that to the center line of the tire. And if those two lines cross each other above the road surface, it's said to have negative scrub radius. And what the scrub radius does is actually creates the pivot point that the tire pivots around. So in this case, on negative scrub, where we're projecting the load to the outer side of the tire, that is now where the tire pivots around. And the negative scrub typically causes a toe-in tendency. We started using negative scrub when we went to a lot of front-wheel drive cars, and we went to a diagonal split braking system where now if we get a brake pull, let's say we lost half of our brake system, our proportioning is 80% front, 20% rear. This would actually cause the tire to now pull into the vehicle instead of pull away from the vehicle, and thereby reducing chances of losing control. So negative scrub was brought in for, a couple of reasons, but that was one of the primary ones. If we go to the short long arm suspension, you can see now that the intersection point is going to be below the road surface. And we actually call this one positive scrub radius. And so there's our pivot point for this one. And the natural tendency of this unit is actually to toe out. So again, when we're teaching alignment, quite often we talk about SLA suspension and, the tendency where you set toe in. Well, typically you do set toe in on an SLA because there's the dynamic function of toe is that once those wheels get rolling down the road and start using this dynamically, they're going to toe out naturally because of that pivot point. So, we typically set toe in on a SLA suspension somewhere in that 1/8 inch range. And then as the vehicle started moving, you're going to start tightening all of the steering linkage and, hopefully get the tires going straight down the road. Oops. One of the other things about steering axis inclination we use is that we use it for returnability of the steering wheel. Now, I'm showing the spindle arc in this red line here, where it's just kind of this way. But of course, the spindle also rotates around the axis. So it's going to create an arc, kind of like a plate on its side. And the high point is always in the straight ahead position. So after you've completed a corner or whatever, this thing is going to want to return back to that point because that is the high point and the load of the tire pushing on that, and it wants it to go in that straight ahead position. Another part of steering axis inclination that we talk about is the included angle. Steering axis inclination is a measurement from the center line of the tire through the imaginary line of the two pivot points, but then we also have camber, which again is the imaginary line through the center of the tire and where we've got the tire lean to. So if we add SAI and camber together, we get what is known as the included angle. the included angle. Typically, camber being positive in this case, added to SAI. But there are times when you could have negative camber. So if you add a negative and a positive number, you actually end up with a smaller included angle than you have for SAI. Camber adjustments on front-wheel drive cars. There are some front-wheel drive cars that actually move the upper strut mount to achieve their camber adjustment. The camber, in this case, by moving the top of the strut out on top, is going to give us positive camber, and our included angle is going to remain the same because it's a function, again, of the SAI and the camber all put together for our included angle, and because we're moving the spindle with it, the included angle stays the same, even though we are changing SAI and camber. And same thing if we move it in, the included angle remains the same. We've changed SAI and camber. If we go to a fixed strut position at the top and then adjust at the lower strut point. So the lower strut point is where we might have an eccentric mounted in the place here where we have an eccentric bolt on one of the strut bolts, and that would allow us to tilt the wheel in and out. So that's what we talk about camber using lower strut mount, and that's probably a more common adjustment. Sometimes on cars that didn't have any adjustment, you can buy aftermarket kits to put in there and create this adjustment. So in this case here, we've angled it in. So in this case now we've changed the included angle because we've actually kind of bent the system because we're adjusting it in the middle. So SAI stayed the same now, but we've changed the included angle in the camber. And same thing if we move it out, the top of the strut is still in the same location, so is the ball joint. So now the SAI is still the same, but we've changed the included angle again. So those become important when we're doing later, and something we're going to talk about tomorrow is getting into some diagnostics using this process. Now, scrub radius and tires. When we talk about tires and changing tire sizes and things like that, we can start getting into scrub radius and the effects that we have on it by changing tire size. For example, here, I've put a larger diameter tire on here, not only a larger diameter, but wider. And what did it do to my scrub radius point? So you can actually see that my load point has moved. Oops, went too far. By going to a larger tire. Same thing if I go to a smaller tire. The place I'm projecting the load doesn't change, but the contact patch of the tire and its location. This can be affected by wheel offset, tire size. A lot of things can affect this without changing the adjustment at all. So it's something else to consider as people get into modifying vehicles. Similar considerations here. If we get into changing things about this system, where we've got our upper and lower control arm, if we were to increase the offset of the tire, increase the diameter, increase the position. Other questions I have too about this would be, what happens if I decide that I want to change the ride height of this vehicle? A lot of people will say, well, you just put lowering springs in. But if you think about what lowering springs might do, is we're actually going to change the angle of both my control arms. on top of creating an issue with ride, it's actually going to change a lot of the dynamics. One of the things that may also be done is drop spindles, where we actually physically change the location of the spindle on the knuckle itself. So we can change the spindle so that we move it up here. And if we move it up there, that's actually going to lower the vehicle without altering anything else over here. If I drop that down, so move the spindle down in location, we have to start worrying about clearance. But again, that could raise the ride height of the vehicle. So it's kind of weird when they talk about a drop spindle, is that a drop spindle lowers the ride height of the vehicle, but we take the spindle itself and move it up on the knuckle to create a drop spindle. And I talked about modifying instance center inboard to instance center outboard. And one of the ways that's done is you can find all kinds of kits for a lot of the older vehicles where you can actually get a taller spindle. So that means you get here and we can put a taller spindle, which is going to change where the upper control arm meets, and again, change the arc path that it travels in. Some other ones are getting taller ball joints, those types of things as well. So getting into using this for us a little bit. In this diagnostic scenario, we've got a vehicle that's come in and we get some readings off of it. And we can see here that we've got Camber at a -2 on the left side and Camber of +2 on the right side. Steering axis inclination of 12 on the left and 8 on the right. So the included angle, if we take the Camber -2 plus the SAF 12, we end up with 10 degrees of included angle. And if we look over on the right side, we've got +2 and SAF 8, so we have the exact same included angle of 10. So as I said before, we've got a negative and a positive number, add them together, gives us our 10. And the same on the right side, we got a positive number and a positive number, so we've got 10. So we're looking at this and, you know, it would be easy to come along and say, well, I need to adjust the camber on this wheel over here and use one of those kits. And let's say my spec is 1 degree. So I would put a kit in here and set this one at 1 degree positive and put a kit over on this side and set it at 1 degree positive. And now I've got the same SAI, but I've probably changed my included angles. So if I were to do that on the right side, you know, my included angle is now going to be 9. And on the right side, it's now going to be 13. So there might be a better way to correct this. If I were to take and move the cradle itself along the unibody, that I could actually shift that over. And that's now going to move the bottom of the right-hand side out and the bottom of the left-hand side in. And if I go back to this picture, if I move the bottom of the right-hand side out, that's going to reduce the camber and increase the SAI. So now if my number is 1 degree positive camber, and SAI would now increase by a degree, which would be 9, and I still have the same included angle of 10. On the opposite side, I've pushed it again over that 1 degree. My camber is now going to change SAI is going to change, but the included angle would again remain the same. So in this case, when a vehicle was non-adjustable, it was a matter of something being out of place. So that's one scenario where we can actually use this as a diagnostic and get into reading these numbers. Now, when you go to do an alignment and want to get these numbers, you can, on most alignment machines, set it up to measure SAI while you're doing your caster sweep. You actually have to do it, requested. In my experience with a lot of alignment machines, various ones will do it different ways. But I usually used to say to measure SAI and included angle. But one of the other things we used to do is to take suspension loading out of the question was actually do a raised measurement, which means, again, my experience being with a lot of hunter equipment, you could actually raise the vehicle up and do your caster sweep with the wheels in the air so that you would get all of these measurements without having suspension load affected. And again, really, when we're measuring caster, remember that all a caster sweep is we're measuring the amount of camber change through a defined angle, meaning we're sweeping 20 degrees in, 20 degrees out, and we're going to read the camber change as we do it, and that's how we calculate caster. Now, the second part of this, which we're going to get into, is going to be talking about caster change and how that affects camber and some of the other things that go on with our dynamic wheel alignment.
You've got 3 minutes, Rick.
Yep.
Tell me when you want to put that sign.
Yeah, so I think that's, we'll stop there for the day, and we'll get back to put up the piece that you've got, Jeff, and then we'll show that. And then, like I said, we're going to continue with this tomorrow and carry on the conversation.
Okay, so I pushed out a just a sign-up sheet for you to fill in so that we can get you certificates when we're back on operation at the office. So if you would fill that out. I've also again thrown in a third question that shows an image. Creative Commons, I'm just trying to test out our ability to be able to push images in that method with the forms. So wow, the stuff with the hands, Rick, that's cool. That's in front of the screen is really nice.
Okay. I guess that would be some of the comments too. Is this a valid way to do this?
Well, I mean, I personally think that maybe on Thursday, you can maybe kind of go behind the scenes and show how you pulled this off with the green screen, and maybe what does it take for someone who may want to also attempt such a thing with their students, like what would they need and all that, because that's pretty cool.
Rick, as far as hardware is concerned, does every instructor watching this presentation today have the hardware that they need to do this? And is it mostly software?
A big part of it is software that I'm using. A lot of the switching I've done, I'm using actually something called a Stream Deck that a lot of the online gamers use. But you don't need to do that. You can use all your keyboard or mouse. There's buttons in the software to do it all. Really easy, probably not quite as elaborate, is the software for doing green screen. I know Logitech video cameras, I found a little piece of software called Logic Capture, where you can actually go in and use your Logitech webcam and actually do chroma key with it and set something up. Big things I found in doing this are getting an actual green screen, and then the other one is lighting. Is, you gotta light the thing properly, and that's part of the things I'm learning. But It hasn't been too tough.
Hey, Rick, Tyler
Rick,
asked.
Tyler, I'm sorry.
Jeff and I were getting to the exact same question. Somebody wants to know what the advantage would be to a raised caster sweep. They kind of missed what you were saying on that.
So that you're measuring your included angle in your SAI without any suspension load. So one of the things that can happen when you've got the vehicle on the turntables is that, again, you're fighting that arc that the SAI wants to make with the tire, because the spindle is actually pushing the vehicle up as you're doing it. So if you do it with the wheels raised, there's no loading of the suspension at all. It's just purely the movement of the tire angle through its sweep instead of having load on it.
All right, I'm going to stop the recording.
And for the